Okay, welcome once again for you. So in our today's class we are going to discuss about a problem on a cylinder. I hope you know what is a cylinder. So this is what a cylinder which has a base as a circular and a top as a circular. It is formed by a solid of revolution when with the center, if I revolve a rectangle, I have a cylinder. So this is my base and this is my top. So it is having some imaginary directress. It is called as imaginary directress. Okay, so let us you can see the problem very clearly in the description. So what is given here is it is having a cylinder of a diameter 30 mm and the axis length of 50 mm where it is resting on point on a HP. So let us consider this is my base. One of a point in this particular base is resting and inclined at an angle of 45 degree to HP. So imagine this is how it is resting initially and only one point is resting and it is inclined. So this is the final position of the solid what we have to draw. So axis is inclined at 45 degree to HP and it is parallel to VP. Since it is given very clearly, see here I have made a point. So I have drawn a circle of diameter 30 mm by taking 15 mm in radius in my compass. I have drawn this circle. I have divided this circle into 8 equal parts, and obviously you know that I have a base and I have a top. For the base I have been used as alphabet and for the top I have been used as the numbers. When I look from the top, only the number is visible, the alphabets are not visible. See here 1, 2, 3, 4, 5, 6, 7 and 8 which is outside the bracket, and at the bottom I am having the base which consists of alphabet A, B, C, D, E, F, G, H. So then what I did is I have projected all these points. You can see these 2 and 8 will be in the same line, 3 and 7 will be in the same line, 4 and 6 will be in the same line, and 5. And I know the axis height given is 50 mm. First what I have done is I have just projected my axis line and I have marked 50 mm and then I have projected all the points and I completed my front view. So you be very careful. When I look from here I can see 1, 2, 3, 4, 5. But I have drawn only 1 and 5 is dark here. The reason behind this is all other remaining things are imaginary directress for me, so that I should not draw all these things very darker. So on image you see here the 3 and 7 is not drawn darker since I am having only my center line. It is the procedure similar to that of a cone. The cone and cylinder follows the same procedure. This is about your simple question. So now let us go into our inclined question. It is clearly given that resting on a point on a HP and the axis is inclined at 45 degree to HP. So we know that obviously if it is given axis is inclined, we need to find out the base is inclined. I already told that 90 minus 45 which is nothing but 45 degree which is for your base inclination. So now I have to draw the base inclined at the angle of 45 degree. So for which I am fixing this point phi and E, for which I am taking a point here and I am mentioning it as a E. See here, it's in the bracket E1 dash. Okay, now I am drawing a line which is inclined at an angle of, so now I am drawing a line which is inclined at an angle of 45 degree. Okay, now I have to transmit all this point E to D, E to C, E to B and E to A. With the help of a compass, I have to measure from E to A. I cut an arc. So this arc should not even visible. So it should be very light and very thin. So here I am having my A1 dash. Then you measure E to D. Here I have my D1 dash. Within the bracket F1 dash. So from E to C, you can see E to C. So this point is C1 dash. Within the bracket it is G1 dash. So now we can measure A to B. So from A I am measuring B. So here I am having my point B1 dash within the bracket H1 dash. Obviously you know that this baseline, so this vertical line is perpendicular to this baseline. So what you have to do is, now you try to draw a line which is perpendicular to these points. Okay, so now let me draw it like this and make sure that it has an axis height of 50 mm. And you know that obviously only the outermost part of your rectangle should be darker. So that I am converting this as a darker one. And parallelly I have to give the name at the top. You can see here, this is my 1 dash, this is my 2 1 dash, within the bracket 8 1 dash, this is my 3 1 dash, within the bracket 7 1 dash, this is my 4 1 dash, within the bracket 6 1 dash, and this is my 5 1 dash. So now I have completed the inclined front view. Now what I will do is I need to draw my inclined top view, which is the final question, for which what I have to do is simply project all the points from the top. Don't forget to project all the points. It is very very important. So I am trying to project all the points from the top. So this vertical line should be perpendicular to my reference line. Make sure that it is perpendicular, and don't even forget a single point from your front view at the top. And similarly, you try to project all the points from here, where these points should be parallel to your reference line. So these points should be parallel to your reference line. So it is very very important. See here, obviously I have been projected all the points from there. Okay, so now obviously you know that what are the points available. Since you can see here, this is the resting point. This is a resting point which is nothing but E1. Here I can write as A1. This is my point B1. This is C1, and this is D1. So this is F1. This is, and this is finally H1. And similarly I can write it here. So I can have my point here as, so this is my point, I think so. Where is it? This is 7. So here I am having a 7. 7 1. And then having my 8 approximately here. 8 1. This is my 1 1. This is my 2 1. This is my 3 1. This is my 4 1, this is 5 1, and this is 6 1. So obviously you know that here a corner is resting. You don't mix up with your prism and a pyramid. In case of a cylinder and a cone, you see here a corner may rest, a side may rest. So basically a corner only will be resting. If E is resting, from E to G, you can see here, from E to G, it should be a hidden line. You can use your French curve, which is available along with your set square, and you try to complete the diagram. And if I look from the top, I can see the entire circle. Again you use your French curve. To complete the diagram. Okay, as I told you earlier, only two directors should be joined. So I am joining here as G to 7 and 3 to C. So that's all. The problem is completed. So here the dimension part is, I need to dimension this angle. You be very clear. You should not dimension your base inclination. Only your axis inclination, which is your 45 degree. And you know the diameter of the circle is given as dia 30. So first you need to complete by having an arrowhead, and you try to mark it as a dia 30. And you know that obviously you need to have your height of your cylinder, which is given as 50 millimeter. You draw your extension line, you draw your dimension line, and the height is given as 50 mm. So this is your simple position, and this is your final inclined position.